The other half of that great partnership that has come together to found and nurture the laboratory is the Department of Energy and the National Nuclear Security Agency. I'm very pleased that we have with us today two representatives of the department. First, Tom D'Agostino, who's the Administrator and Undersecretary for the National Nuclear Security Agency. He and his predecessors have provided unwavering support for this project through difficult times and through wonderful triumphs. I've known Tom and worked with him for a very long time, and I've always known where his heart was and that his eye was always on the long-term vision. So it's been a great pleasure to work directly with Tom these last few years, and I'm really pleased, Tom, that you could come talk to us today.
Thanks very much, George, and good morning. On behalf of the Department of Energy and the National Nuclear Security Administration, I congratulate all of you today for this great accomplishment, and really thank you for your hard work. This is a great day for science. However, it's also a great day for national security. I have a special draw to our nation's security, not just because of my current position as the administrator in the NNSA, but of my 27 years of active duty and reserve time serving the United States Navy as a naval officer in the submarine force. For more than a Thank you. I'll also add, I'm sure there are plenty of other folks that are serving in their armed services out there in the audience that have served time, and those folks are really, truly special and remarkable. And I know in many cases that's what drives them to work, and I really want to thank those folks, and they do deserve a hand, not me. For more than a decade, our political and military leaders and our dedicated scientists and engineers who care about our nation's security have supported the National Ignition Facility and, more importantly, the data, the experimental data that we're going to get out of this facility. As Secretary Pena said during the groundbreaking, as we heard May 29, 1997, NIF will help assure the national security, the economic health, the energy security, and scientific leadership of the United States. We have long held expectations for the National Ignition Facility, expectations that we will now put to the test. With confidence in Ben Franklin's admonition that energy and persistence conquer all things, we anticipate many new discoveries and opportunities. But the milestone we celebrate today truly was a team effort and a fitting tribute to the energy and persistence that Ben Franklin spoke of. This was a team effort that included Charlie Curtis, who approved the start of construction while serving as the acting Secretary of Energy, along with 8 other consecutive Secretaries of Energy to make this vision a reality and get to this day. It was a team effort with the Fusion Policy Advisory Committee and the National Academy of Sciences review in 1990 that helped refine the National Ignition Facility concept and start it towards realization. It was a team effort in the early 1990s that included Dr. Vic Reese, who developed the Science-Based Stockpile Stewardship Program. This program couples the research to be done at NIF and other one-of-a-kind tools, such as Sandia's Z machine and the Los Alamos DART facility, couple those with the world's most advanced supercomputers to provide the ability to take care of our nuclear deterrent without underground testing. And finally, and most importantly, it was a team effort by the scientists and engineers and project managers here in the National Nuclear Security Administration, not only at Lawrence Livermore National Laboratory, but also at Los Alamos National Laboratory, Sandia National Laboratory, the Laboratory for Laser Energetics at the University of Rochester, and many other partners. Now we are set to begin using this capability to advance the security of our nation. In the hands of skilled scientists, this facility will contribute to our national security by helping ensure the safety and reliability of our nuclear deterrent, but it will also do this while advancing the skills needed to address emerging national nuclear security needs, or national security needs in nuclear nonproliferation, nuclear counterterrorism, nuclear emergency management, nuclear forensics, and of course intelligence analysis. As the weapons that support our nuclear deterrent age beyond their originally designed lifetimes, our stockpile stewardship efforts become even more important. NIF will allow us to understand that the behavior of those materials at pressures and temperatures that occur in nuclear explosions but cannot be replicated anywhere else on Earth. Now we're on the cusp of the ignition, an accomplishment that has the potential to change the world in the long term and make huge contributions to our nation's security right now. Achieving ignition may be the most challenging aspect of applying NIF for national security purposes, but if we succeed, it will help us understand the most intricate and sensitive process, the boost phase required for a function of our nuclear warheads. The knowledge we expect to gain using ignition at NIF will be critical in our confidence in our deterrent. The NIF and other tools will also help develop world-class scientists and engineers who will address future challenges. In effect, it will develop the varsity science team, I'd like to call it, that this country needs to address a very dynamic and changing 21st century nuclear security and global security situation. As our security challenges grow more complex, I want the varsity science team on the field to defuse improvised nuclear devices and support our nation's nuclear counterterrorism efforts. I want the varsity science team to support the intelligence community on nuclear issues and address an uncertain global security condition. I want the varsity science team to aggressively secure and detect nuclear materials around the world. In this business, the junior varsity team is just not good enough. I'm here to celebrate this great accomplishment and to thank you, but our work is not finished. Together we built this tool. Now together we must put it to good use. So there's a tradition in the United States Navy that goes back to World War I. When a ship or a command does a particularly good job, the commanding officer hoists two signal flags up the yardarm. One flag represents the letter B, or Bravo. The other flag represents the letter Z, or Zulu. For the past 90 years, Bravo Zulu signifies exceptional work. And commanding officers, when conveying a job well done, typically end their messages with this phrase. As administrator for the National Nuclear Security Administration and as your commanding officer, I extend to you a hearty job well done and a Bravo Zulu. Thank you very much.